Hi, I am Ahmed Hanu Wahab, preferred to be called Anu. I'm a PhD student in the Department of Electrical and Computer Engineering at Clarkson University, and my advisor is Dachin Hao. Today, I'll be talking about utilizing keystroke dynamics as additional security measure to protect account recovery mechanism. First, you ask, what is account recovery mechanism? I believe you have seen this before, or this, better still this. I know by now you can see that it is quite ubiquitous across multiple applications. Why is it common, you ask? It's because users are found using single password across multiple applications, which makes it very easy for an impostor to attack such an account. What is the easy way out? These users have been asked to use long and different unique passwords across multiple applications. However, these users find it very difficult to remember these passwords, and as a result, they trigger the forget password mechanism or the account recovery option. What are the common approach for account recovery? Users are asked to type in their email address where the account recovery link will be sent. But we know that these credentials or users' credentials can be hijacked or stolen through brute force attack, credential stuffing, or phishing. So if an impostor have access to users' credential, such an impostor can gain access to users' accounts. What is our proposed method? We believe that we can secure account recovery mechanism by using keystroke dynamics. What is keystroke dynamics? First, users have a unique way they interact with the keyboard and the mouse, which makes every user unique. The study of the way users interact with the keyboard is called keystroke dynamics, which can be used for authentication. We have used our account recovery dataset, which has 44 users and over 500,000 keystrokes when user fills this form. We have collected this information from users, their first name, their full name, their email, their address, their city, zip, phone, and declare statements. This is the declare statement. We have used the down-down diagram, which is the timing information between the press of a key and the press of the subsequent key. Meet Alicia. Let's say Alicia forgot her password and triggered the account recovery option. So she is to fill this form. So while she filled the form, we have recorded her keystrokes, which is a typing pattern. So this is what happened on the background while Alicia fills the account recovery form. We have Alicia's profile. The information of the keystrokes collected while Alicia filled the form is called the unknown. We pass these two information into our algorithm and a score is generated. If the score is greater than a particular threshold, then Alicia is an impostor. However, if the score is less than the threshold, then Alicia is the true owner of the account. We have used 5 different algorithms in our research, and we realized that scaled Manhattan distance is the best of all the 5 algorithms. We did further testing and also proved that scale Manhattan remains the best. So we have used scale Manhattan all through this research. We have measured performance based on equal error rates, which is the point at which the false accept rate equals the false reject rate. We have used 3 implementations. The first, we have checked for individual fields, data level fusion, and weighted score fusion. Now to individual fields. We realized that the declare test is the best performance with 5.47% equal error rate. Now to data level fusion. Remember Alicia. Now we collected Alicia's full name and Alicia's address. We lump this information together and pass it into an algorithm. And we generate a score. Then we make a decision based on the score. The result from the data level fusion, we achieve 0% equal error rate at this number of comparisons. The number of comparisons is the number of times our algorithm is triggered. Now to weighted score fusion. Remember Alicia? We collected her full name pass it into an algorithm, generate a score, we call S1. We collected our address, pass it into an algorithm, generate a score S2, for example. Then we pass these two information into weighted score fusion. This is what happened in the weighted score fusion. We find W1, which is the optimum weight for S1. We find W2, which is the optimum weight for S2. We sum these two together and generate a new score. We make our decision based on this new score. The result for the weighted score fusion, we have 0% equal error rate has a much higher number of comparisons. You ask, what does 0% equal error rate means? This means that we can perfectly differentiate between users by the way they type. Now, take for example, an attacker or an impostor have access to Alicia's personal information and account credentials and attempt to attack Alicia's accounts. So when the impostor fills this form, such an impostor will be denied access because their typing pattern does not match Alicia's typing pattern. So Alicia's typing pattern is completely unique and is used for authenticating her. Our result outperforms the state of the art in both fixed test and free test keystroke dynamics. If there are any questions, please feel free to drop them at the comment section and I would love to attend to them. Thank you.